All right, we are looking at a shape on the paper there. That's a full circle, but if you look at it very well, I made a quarter of that circle on blue. So that quarter circle or the quadrat of that circle is what we are going to look for the perimeter. Remember that perimeter is the sum of all the distances around any shape. For example, a triangle. If you are looking for the perimeter of a triangle, simple. Add the three sides. That's the perimeter. If you are looking for the perimeter of a rectangle, simple. Add the four sides. That's all. Now, for a circle as well, it's going to be difficult for us to get the distance around that curve for addition. No, so we have a formula for doing that. Now, for a circle also, we can say we are looking for the perimeter. We have another word we use interchangeably for perimeter of a circle, and that is circumference. So when you hear the word circumference, it means the same thing as a perimeter of a circle. Mind you, we use circumference only for circle, not for any other shape, but it still means perimeter. Is that okay? Now, I told you that the perimeter of a circle is equal to 2 pi r or pi d. R is the radius, while d is the diameter. And I told you the relationship between r and d. I told you that d over 2 is equal to radius, or 2 radius is equal to d. You know that if you have a diameter and you divide it by 2, what you have is the radius. Or if you have a radius and multiply it by 2, that is the diameter. Now, so what I'm concerned here is that the formula for the perimeter or the circumference of a circle is 2 pi r. Now, you are going to see a little difference when we're going to look for the perimeter of this quadrat. I have shown you before, and that is the essence of me making this video. I want to make these things sink and show you why it is the way we are doing it. Now, if we are looking for the perimeter of the quadrat, perimeter of quadrats or this shape, this is R, this is R. Now, if I have here as A, B, and C, sorry, let me put here 0, sorry, O. Now, there's this shape. Now, if I'm looking for the perimeter of this shape, it's going to be equal to length of arc AB plus radius. Now, when I say arc here, what do I mean by arc? This curve that runs from A to B is the arc. If I know that length, I add with radius AO and add with the second radius OB, then I have found the perimeter of that shape. Now, how do I get the length of that arc? Now, the length of that arc is a portion of the total circumference of a circle. I hope you know that from where I cut it from. The length of that arc AB is a portion or a part of the total circumference of a circle. Now, the formula for that arc, length of arc, AB is theta over 360 times 2 pi r. That's the formula we're going to use to get length of the arc. What is theta? Theta is the angle that the arc makes with the center of the circle. I take it again. Theta is the angle the arc makes with the center of the circle. In this case, my theta is this, and it's 90 degrees because it is a quadrat. It could be any other angle. It could be 30, it could be 60, it could be 120, 270, and so forth and so on. You have been solving with that. The theta in this case is 90 degrees. So, the length of my arc becomes 90 over 360 times 2 times 22 over 7. Remember, pi is a constant, which is always 2.22 over 7 or 3.142. Of course, if you divide your 22 over 7, you'll get 3.142. Then times the radius, which is 14. Of course, you can put this over 1. That's mathematical. So what do? I evaluate. This 0 cancel this 0. 9 here, 1, and 9 into 36 is 4. 7 here is 1. 7 into 14 is 2. These 2 will give me 1, and these 2 will go into 4 to give me 2. And of course, these 2 will cancel out each other. So length of arc is simply 22 cm. Do you see that? So I have gotten all the sides of this quadrat now. So perimeter of quadrat or shape is simply equal to the length of the arc, which is 22, plus the first radius AO, which is 14, plus the second radius OB, which is also 14. Now, if you add this one, you are simply going to get 50 centimeters. That's all. That's all. Now, one question you should ask me here, or if we were live, you should have asked me is, why is the perimeter of a circle simply 2 pi r, but the length of an arc is theta over 360 times 2 pi r? I mean, you should ask that question, but it's very simple. The reason is that if I'm looking for the arc of a total circle, which is something like this, the arc of a total circle, which is, take this as my circle. Now, this is the center. In this case, the angle we are talking about here is 360 degrees. So my theta is 360 degrees. Therefore, if I'm going to use the formula of theta over 360 times 2 pi r, you are not going to see that since theta is 360, I'm going to have 360 over 360 times 2 pi r. Now, of course, 360 will cancel 360, and I'm going to have simply the circumference. I'm going to have the circumference as simply 2 pi r. So you see the reason why the circumference or the perimeter or the length of the arc of a full shape does not have that theta over 360, because theta is 360 and 360 over 360 will give me 1. But if you are calculating, if you are finding the arc of any point portion of a circle. Listen to my statement. If you are looking for the arc of any portion of a center, then theta cannot be equal to 360. Then you must use the formula theta over 360 times 2 pi r. I guess you got it here. Now I'm going to send you some more questions based on calculation of perimeter of things like quadrat or some other sectors of a circle. Remember, I can give you a sector whose theta could be 30 degrees, 60 degrees, 180. Of course, for 180, that should be a semicircle. 270, 280, 300. Theta could be any of those angles. Your radius should always be given to you. So I hope going through this little video, you should be able to find the difference in finding the perimeter of a sector of a circle and an entire circle. We'll see on Friday and Saturday.